Hi everyone, welcome to Homeschooling channel. Today we are going to start a new chapter in mathematics. In this chapter, we are going to have 3 videos, each video consisting of 10 to 15 questions. In the first two parts of the videos, we will cover the basics along with questions of low and medium difficulty level. In the third part, we are going to cover high difficulty level questions along with the questions asked in previous years in SAT exam. I'm going to comprehensively cover different types of questions possible from this chapter from various SAT books. One thing I can make sure that even though you have never read this chapter before, after sincerely watching all 3 videos in this chapter, you will be able to solve any questions related to this chapter asked in future SAT exams. I want you to take out your notebook and pen and start solving these questions along with me. So let's go. So this is our syllabus here. We are going to cover this chapter, geometry and trigonometry, circle. In this chapter, you're going to get maximum 1 to 2 questions, not more than that. Okay, so this now let's start with the basics first. So this is a circle is a set of all points which are at constant distance from a fixed point. So if this is your center and there is a point at a distance r, so if you put points like this of r length everywhere, then it will form a circle. You know, a lot of points if you put like this, it will form a circle. So circle is a set of all points which are at constant distance, that is the distance of the radius from a fixed point, that is your center O. Okay, now properties of circle. All radii of same circle are congruent. So if this is one of the radii, if this is R1, if we have another radii R2, then both the radii are congruent or same. Now a central angle is an angle whose vertex is the center of. So let's say this is a this angle extended from the center, like angle COD. Angle COD is called as central angle. Any angle that is subtended from the center of a circle is called central angle. It can, the central angle would be angle AOB, angle FOC. So these three angles would be central angle. Now what is a chord? So chord is a line segment whose endpoints are on the circle. So a line segment whose, so this is your chord because their end point is on the circle. Let's take it here in, let's say this CD is your chord because you can see endpoints on the circle. Similarly, FE is also a chord, then AB is also a chord. Now there's one more property: equal chord of a circle subtends equal angle. If all these three chords A, B, C, D and E, F, all these three chords are equal, then the angles subtended by them, like this angle, and this angle, all these three angles would be equal. Or if angles are subtended from the center are same, then the length of chord would be same. So or vice versa. So if chords are same, then your angles would be same. If your angles are same, then the length of the chord would be also same. And there's one more thing: longer chord is nearer to the center than the smaller chord. See, this one is a smaller chord, if we take another longer chord, so as you can see, the longer chord, this one is nearer to the center, and the shorter chord, if you take another shorter chord, this would be far away from the center. Next, properties of circle. The line drawn through the center of a circle bisects a chord, and its arc is perpendicular to the chord. See, if this is a chord, and if we take a line from center to which it bisects to the chord, then it then that line is perpendicular to the chord. So OM line, if it passes through the center and it bisects the chord, then it is perpendicular, and it is, and the vice versa is also same. If uh, the vice versa would be, if if the OM is perpendicular to AB, then these two would be of equal length. Then AM and MB would be of equal length. So you have to remember these properties. Now, next property, equal chords of a circle are equidistant from the center. So in this one, if length of CD and chord CD and chord AB are of equal length, then the length from the center O would be same. So from this we can say that OM is equal to ON. If chord AB is equal to CD, then length from the center, this would be same, OM and ON. Now, and the vice versa would be also possible. Okay, now an inscribed angle, so any angle that is on circle is called inscribed angle, and any angle that is at the center O is called central angle. So this property says that inscribed angle whose vertex is on a circle, okay, is its measure is half of the central angle. So angle PAQ is half of angle POQ. So this angle would be half of this angle. So you have to remember this property. You have to solve a lot of questions on this property. Now let's take this one, major arc and minor arc. So if we have a circle here and we extend two lines like this, so the smaller area PQ, this is going to be the minor arc. The smaller arc would be called as minor arc PQ, and then the remaining arc PAQ, this would be called as the major arc. One more thing in that the relation between central angle and inscribed angle. Let's say, let's take this figure. Okay, as we have read, this angle is can also be half of this angle also. So there might be some questions like this, so you have to remember this one, that inscribed angle is half of the central angle. So you can find few questions like this also. Now as we know the relationship between, now put this one in this figure. Like if this is the diameter, okay, it is passing through the center O, so the angle would be how much? 180 degree. Okay, so what would be the inscribed angle? It is going to be half, that is 90 degree. So you can prove this from this one. Okay, so an angle inscribed in a semicircle, if we remove this thing, okay, if lower half, and if we just take this portion, in a semicircle, then the angle inscribed would be 90 degree, and you can prove it from that because the central angle, the inscribed angle would be half of the central angle. Or if chord passes through the center, so this is the chord passing through the center, or it can also be called as diameter, then the inscribed angle is right angle. So this angle would be a right angle. Okay, if a line is passing through the center, or if it's a diameter, then the angle inscribed from it would be 90 degree. This is also a very important property. If two arcs of a circle are congruent, then their corresponding chords are equal. Let's say these two arc CD and arc FE. If these two are congruent, then their corresponding chords, the straight line FE and CD, would be equal, and vice versa. That means if the chords CD and FE are equal, then their corresponding arcs, this one and this DE, DC, they would be congruent. Now, congruent arcs of a circle subtend equal angle. So if this is CD is an arc and FE is an arc. So if both of the arcs are congruent, then it will have equal angles. So this angle and this angle would be equal because arc FE and arc CD are congruent. Now let's come to a concyclic or a cyclic quadrilateral. Okay, a, a quadrilateral is said to be concyclic if all the four sides touches the circle. As you can see, in a quadrilateral we have four sides, so all the four sides are touching the circle. So these type of quadrilateral are called cyclic or concyclic quadrilateral. And the property of cyclic or concyclic quadrilateral is that the sum of their opposite angle, like these two angle, the sum of their opposite angle, angle A and angle C, would be 180 degree. Similarly, these two angles, opposite angles sum would be 180. So angle B and angle D would be 180 degree. Now let's solve some questions. So in this question, in figure AB, in figure A, B, C are 3 points on a circle with center O, A, B, C, okay, with angle BOC. So angle BOC is 30 degree and angle AOB is 60 degree. Okay, angle AOB is 60. If D is a point on the circle, so D is here, point on the circle other than the arc ABC. Okay, so this is going to be an arc because this is a smaller arc, so this is the bigger arc, so it would be here. Then find angle ADC. So we have to find angle, so this is an inscribed angle. So as we have read, inscribed angle, angle ADC is going to be half of central angle. So we will take the whole as a central angle. Okay, we will 60 plus 90, so angle AOC. So angle ADC would be half of 60 plus 30 would be 90. So half would be 45. Hence the answer would be angle ADC is equal to the, so answer would be 45 degree. In this question, we can see that in figure angle ABC is 69. So this angle ABC is 69 and angle ACB, angle ACB, this is going to be 31 degree, not the full angle, just this part only, 31 degree. What is angle BDC? So we have to find this angle. So as we know, the sum of a triangle is 180 degree. So in triangle ABC, so this angle B is 69 plus angle A, we don't know what is that, plus angle C, that is angle 31, and we are taking this triangle ABC. Okay, so the sum of their angles would be 180 degree. So angle A plus 69 plus 3100 is equal to 180. So angle A is equal to 180 minus 100, that would be 80 degree. So as we have read in the properties that the angles subtended by the same chord would be same. So this is a common chord BC, and the angle subtended uh, by chord BC is angle A and angle D. So angle A and angle D would be same. So from this property, angle BDC is also equal to 80 degree. Now moving to the next question. Two circle of radii 5 centimeter and 3 centimeter. So this one is the larger one, 5 centimeter, and 3 centimeter. The smaller yellow one is 3 centimeter. Intersect at 2 points. Okay, intersect at 2 points, point A and point B. Between the center, there's between the distance between their center is 4 centimeter. So O dash is 5 centimeters center, 5 centimeter radius circle center, and O is 3 centimeter radius circle. So distance between them would be how much? 4 centimeter. So we have to find what is the length of the common chord. So as we can see, AO and OB. So what we are going to do here is, let's say O dash is 4 centimeter, O dash is 4 centimeter, O A dash is 5 centimeter, and we are taking the we can, this is a radius, so of the bigger circle, so it would be 5 centimeter. Similarly, like this is the radius, so it can be a 5 centimeter. And OA, because from here to here, this is going to be this radius of the smaller circle, so 3 centimeter. So we have to find what is AB, is what is AB. So as we can see, this is also the radius and this is also the radius. So AB is equal to AO plus OB, which is equal to 3 plus 3. Final answer would be 6 centimeter. Now moving to the next question. In figure, A, B, C, D are 4 points on a circle. A, B, C, D are 4 points on a circle. AC and BD intersect at point T. AC and BD intersect at point A such that angle BEC is equal to 130 degree. So this angle is 130 degree and angle ECD is 20 degree. So what, find angle BAC. So we have to find angle BAC. We have to find this angle here. So as we know, uh, In triangle we have read a property that if this is a triangle, and so this exterior angle is equal to sum of two interior angles. So similarly here, if we consider this one as a triangle, okay, and this is 130 degree, and this one is 20 degree. So as we have read in triangles chapter, that exterior angle is sum of these two angles. So 130 degree is going to be 20 degree, that is angle DCE plus angle EDC. So angle EDC is going to be 110 degree. So this is going to be 110 degree. Now as we know, both the angles are formed from the same chord, so angle D is equal to this angle A. So from this ang angle BAC is equal to angle EDC, which is equal to 110 degree, as angles are subtended from from same chord. If you like the way I teach and want to buy a comprehensive course for SAT exam at a very affordable price, you can download our app from the App Store and start your self-paced preparation from pre-recorded videos provided in the course. My course also includes chapter-wise practice questions along with 20 test series at par with SAT exam. You can find all the links in the description below. Now let's move to the next question. Now in this question in figure, angle PQR is 100. So angle PQR is 100, where PQR are points on a circle with center. PQR are the points and the center is O. Find angle OPR. So we have to find angle OPR. So we have to find this angle. So as we know that inscribed angle that is angle PQR is half of central angle, that is this part. Okay, central angle POR. So inscribed angle is 100. So if we take 2 on that side into 2, then the central angle POR is equal to 200 degree. Okay, so this is going to be 200 degree, and as we know that the sum of all the angle the angle of a circle from a center, the whole thing would be in a circle would be 360 degree. So what is going to be this angle? This angle is going to be 360 minus 200, so it is going to be 160 degree. So this angle is 160 degree. So total they form 360 degree. Okay, now let's, as we know that this is the center and OR and OP is radius, so both of them would be same. So as we have read in triangles chapter that angles opposite to the equal sides are also equal. So as we know, POP is equal to OR, as both are radii of the circle. OP is equal to OR. So opposite angles, that would be angle ORP is equal to angle OPR. because it angle opposite to equal sides are always equal. So we know that these two angles are equal, and in this and now in triangle OPR, this triangle OPR, the sum of all the angles would be 180 degree. So angle POR plus angle ORP plus angle OPR is equal to 180 degree. As we know, angle POR is 160 and both the angles are same, so 180 degree. So 2x, if we take 160 on that side, it is going to be 20, and x is equal to 10. So this angle and this angle, angle ORP and angle OPR, both the angles would be 10 degree each. So the answer of angle OPR is equal to 10 degree. Now let's come to the next question here. A chord of a circle is equal to the radius of the circle. This is the chord AB is equal to the radius. So if this is radius, this is also a radius, and the length of the chord AB is also equal to the radius. So this is an equilateral triangle. So in equilateral triangle, all the angles would be 60, 60, 60. Okay. Find the angle subtended by the chord at a point on the minor arc. Okay, we have to in the minor arc, this is the minor arc, so we have to find, and also at the major arc, so we have to also find this angle. Okay, we have to find angle D and angle C. So as we know, as we have read in the properties of circle, that inscribed angle is half of central angle. So central angle is 60 degree, so half of it would be 30 degree. Okay, now from this is a cyclic quadrilateral, and in cyclic quadrilateral, sum of opposite angles is 180 degree. So in cyclic quadrilateral A B C D, angle C plus angle D is 180 degree. So as we know, angle C is 30 degree, so angle D would be 180 degree minus 30, which is going to be 150 degree. So the angle subtended by chord at minor arc, this is going to be 150 degree, and at major arc, this one, that is going to be 30 degree. Now next question. Now ABCD is a cyclic quadrilateral whose diagonal intersect at point E. So ABCD is a cyclic quadrilateral, and its diagonal intersect at point E. Okay, if angle DBC is 70 degree, okay, and angle B, this one is 70 degree, and angle BAC is 30 degree. So find angle BCD. So we have to find this whole angle. Now what we are going to do here is, this is your common chord. Okay, and angle DBC is one triangle. Okay, so this angle is subtended from the same chord, and in triangle DAC, the angle this angle DAC is also subtended by the same chord. Hence both the angles would be same. So this is 70 degree, so this is also going to be 70 degree, because angles are subtended from the same chord. Now as we know that this is 70, this one is 30, so in in a cyclic quadrilateral, sum of opposite angles are 180 degree. So this, if angle A is 100 degree, 70 plus 30, 100 degree. So what is going to be this? So 180 minus 100, that is going to be 80 degrees. So whole angle is going to be 80 degree. So we find angle BCD. So BCD would be 80 degree. Okay. Further, if AB is equal to AB, so angle BCD, first angle BCD is 80 degree. Further, if AB is equal to BC, so these two sides are equal. Okay. So find angle ECD. So if this side is equal, this side is equal, then the opposite side, opposite angles would be also equal. So this angle and this angle would be also 30 degree. So find angle ECD. So ECD. So if this is 30 degree, so this is going to be your 50 degree. Hence angle ECD is 50 degree. I hope you are getting what I'm trying to teach here, because in exam you're not allowed, you won't have that much of time to, like write like this. You have to solve everything in front of you like this. On coming to the next question, in figure ABCD is a cyclic quadrilateral. Okay, ABCD is a cyclic quadrilateral in which AC and BD are its AC and BD are its diagonal. Okay, if angle DBC is 55, angle DBC is 55. Okay, this one is 55, and angle BAC, so this angle 45 degree. Find angle BCD, so I have to find this angle. Now let's see what we can uh, do here. Question number 8. Do we have a common chord here? Yes, yes, yes. We have found a common chord in triangle BDC and triangle DCA. So this a triangle and this one DAC, this triangle. So we have a common chord DC. So this angle and this angle would be same because both the angles are subtended from the common chord DC. So if this is 55 degree, so this is also will be 55 degree. So now as we know that this is a cyclic quadrilateral, the sum of these two angles would be 100 degree. So total angle BAD is 100 degree. 45 plus 55, 100 degree. And we know angle A plus C in a cyclic quadrilateral, the sum of opposite angles is 180 degree. Hence angle CBCD is equal to 180 degree minus 180 degree. Hence angle BCD is 80 degree. Now let's move on to the next question here. So this is slightly difficult, or I would say it is a real deal question. It is quite lengthy. So let's start this question. Three girls, Rita, Selma, and Michelle, are playing a game by standing on the radius of the circle that is 5 meters. So the radius OA is 5. Rita throws a ball to Selma, Rita to Selma, Selma to Michelle, and Michelle to Rita. Okay, so they're throwing balls like this to each other. if the distance between Rita and Salma, and Salma and Michael is 6, so these two would be 6, and BC AB would be 6 each. What is the distance between Rita and Michelle? Michelle. Okay, so we have to find what is AC. Okay, so how we are going to approach this question? Let's see. Mm, as we know, AB is equal to BC. So these two sides are equal. So these two angles, hence angle A B M A B is equal to angle MCB. So they are opposite angle of equal side. Anything else that we can draw from it? No, no. So this is an isosceles triangle. So the of equal, it has two equal sides. So opposite angles would be also equal. Now, as we can see, BM is the angle bisector. So the side these two will be also equal, as BM is perpendicular bisector. So we can write AM is equal to MC. Now, okay, now let's consider a few things here. If we have to find AC, so let's consider a few things here. Let AM is equal to Y. We consider this one as a Y, and this is a perpendicular bisector. So this MC would also be Y. And OM, let us consider OM is equal to X. OM is X now. Okay, so now in triangle A, AOM, so if we apply Pythagoras theorem, so AO square is equal to OM square plus AM square. Okay, so 5 square is equal to OM, we have considered it as X, and AM X square, and AM is Y, so Y square. So let us take this as equation 1. Now let's take the another triangle. In triangle ABM, okay, ABM, if we put Pythagoras theorem, so AB square is equal to BM square plus AM square. Now let's see, OP is the radius, as we can see, and we know OM is X, so BM would be 5 minus X. So now let's put things here. AM square is equal to AB, that is 30. No, we cannot do like this. AB, let's put like this, 36. AB square is 36, BM is 5 minus X plus AM. AM is Y square. So if we write it like this, we simplify it, 25 minus 10x plus x square plus y square. So this is your equation number 2. Okay, so if we subtract equation 1 from equation 2, so if we subtract 5 square would be 25, um, then x square plus y square. If we subtract minus, it is going to be 11. Okay, and then this is also going to be minus, so x square y square y square. 25 minus 10x, so 10x is equal to 14, hence x would be 14 by 10, and that would be 7 by 5, hence x is equal to 7 by 5. Now if we put this one in equation 1, so from equation 1, 25 5 square 25 is equal to x square 7 by 5, so 49 by 25 plus y square. So 6, if we take this one this side, 625 minus 49 by 25 is equal to y square. Let me solve this on a calculator. uh, so y is equal to, after solving we find y is equal to under root 23. Under root 23 would be 4.8. So y, that is am, is equal to y, which is equal to 4.8. Now we have to find the distance between Rita and Michael. So Rita and Michael is AC. AC is equal to y plus y, that is 2y. So hence twice of 4.8 is equal to 9.6. So your answer would be, the distance between Rita and Michael is 9.6 meters. Now let's come to next question. This is also a tricky one. Okay, a circular park is of radius 20 centimeter 20 meter is situated in a colony. So if this is so, then OA is 20. Three boys, Ankur, Sayed and David, are sitting at equal distance on the on its boundary. So let's take let side let each side is equal to x, because in the question it is given sitting at an equal distance. So this is x, AB is x, AC is x, and BC is also x. Okay, now uh, sitting at equal distance on its boundary, each having a toy telephone is in his hands to talk to each other. Find the length of string of each phone. So we have to find what is x string, because all the three strings, so we have to find what is x here. So in properties we have read that if an angle going from center to the chord, then it bisects it, and it is also perpendicular, and it also bisects it. Okay, so if it bisects it, if the whole length was BC was x, so BD would be half of it, as it is bisecting, and DC would be also. So we are going to write BD is equal to x by 2, and DC is also equal to x by 2. Now let's put Pythagoras theorem in triangle ABD. So in triangle, if we put by Pythagoras theorem, so AB, square is equal to AD square, AD AD square plus BD square. It can be also written as AD is equal to AB square minus BD square. After that, if we solve it, AB is X, so and BD is X by 2 whole square. So it is going, after we solve it, 4x square minus x square, it is going to be 3x square by under root 4. So if we take out the root, so 3x by 2. So this is your AD. Now if we know AD, uh, that is 3 under root 3x by, hence see one more thing, there is a concept which we have read in triangles chapter, that if a line is going through the center like this in an equilateral triangle, then the center would divide this perpendicular line in ratio 2 is to 1. That is AO is to OD is equal to 2 is to 1. This is if this is 3 centimeter, if let's say this 3 centimeter, then it is going to be 2 centimeter. AO is going to be 2 centimeter, and OD is equal to 1 centimeter. Yeah, we have read this in triangles chapter, and the name there was a topic called as centroid. So if you have read that topic, you know that AO and OD would be in ratio 2 is to 1. So from this we can write that OA OA is 2/3 of AD. OA, because the whole length is 3 and the length of this, so it will be 2/3 of whole length. Okay, so now OA would be 2/3, AD is under root 3 x by 2. So as we know, OA is radius, that is 20. So 20, OA is 20, and under root 3/3 into x. Hence let's find what is going to be x. X is equal to 3 by under root 3 into 20. So root 3 can be also written as root 3 by root 3 into 20 by root 3. So the value would be 20 root 3. Hence the length of string of each phone x is 20 root 3. This is going to be your answer. This is a lengthy question. It might be asked in you know it might be asked in the exam, because nowadays the questions are getting tougher and tougher day by day. So yes, these type of questions can also be asked, so that's why I have included this here.